Good morning everyone. Good morning. Good morning. Let me know what is the today's date. Good morning Bharatwaj. Good morning. Let's come all the people. Let's come all the people. Yeah, this may be better. This may be much better. This may be much better. Yeah, it's perfect. This is a perfect. This will be more size. If required, we'll see that. This also okay. Yeah, I am writing the problem. I am writing the problem. Today's date is I think 23. I think is it the place where we stopped? Let me check here. So this one we done yesterday. We done this one yesterday. Everything perfect. This was also done. This is also done. Until now, everything perfect. Yeah, this is perfect now. Let's go to next. Today's date is 23 4 26. 23 4 26. 23 4 26. Today's date. So I have one very good problem. I have one very good problem, so I'm going to write it. Yeah, this is the problem. So let me write. I have to manage properly, otherwise it will go to out of the story. So let me write. Hash include stdio.h struct test inside int I char star c. End of this st is equal to 5 become 4 better I will try properly. I will try better. Next one is 6 jungle 8 ancestor 7 brother 8 next main struct test star p is equal to st afterwards p plus is equal to 1 afterwards plus p arrow c. So afterwards just some more space required. Let's move little open. I think interesting thing is main started here. So structure is outside. Yeah, some printf statements are going on, major lines, some printf statements are going on after plus. Let me write. Printf percentage s p plus arrow C, P plus plus arrow C, printf percentage C star plus plus P arrow C, printf percentage D P of 0 dot I, printf percentage S P arrow C. So be careful. This is the main function starting here, ending here. Is the main. This is the upper one structure. This is the upper one structure which contain two field I and a pointer C which contain this data. This is the main function. So first complete. I think I am not able to show total. This is the thing which can I show. Yeah, go ahead. So first one, if you observe, right, struct test int star C. I tried my level best to keep in one page, but it's really not possible. Fine, that's okay. Whenever you say move, I will move. Whenever you say move little bit, I will move. So this is the end of the program. Yeah, try. Whatever you are thinking, you please try a few minutes. I will give the answer. 23rd April. Yeah, I think everything perfect. Everything perfect. Please go ahead. Please go ahead one by one. This is the starting part. This is the starting part. Start doing. Start doing within few minutes. Within few minutes, I will give the answer. I request everyone try. I request everyone try this. Everyone try this. Yeah, let me give answer. I hope everyone tried. I hope everyone tried. Let me give the answer. Can I give answer? So printf statement. If anyone unable to see printf statement, these are printf statement. Can I give answer here? Can I go ahead? First, what you do is, first you people what you do is write the structure first. Write the structure properly. Write the structure properly. I am writing. Write the structure properly. Everyone observe. So this is almost like this. ST is a array. Listen everyone now. ST is a array of this type. Struct test type. One array utility. ST is a array which contain how many people? You know very well. Inside everyone is two people. So two people. Two people. Two people. So two people. So two. So zeroth person, first person, second person, third person, fourth person. Totally, I think five people. So five. Actually, it is a five. So I will write. I will write. I will rewrite again. I will rewrite again. Can you see this? Careful, everyone. Name of this array is ST. Type may be a struct test. Type is struct test. Remember, type is struct test. But it is a array like integer array, right? Struct test type array. What is in that? If it is integer, directly you can use. If it is a structure, so you have to create first. You create it, right? So which internally contain five parts: zeroth part, first part, second part, third part, fourth part. Zeroth person, first person, second person, third person, fourth person. Okay. And one more important thing is everywhere, right? Everywhere two parts are there. Everywhere two parts are there. Everywhere two parts are there. Please try to understand. Everywhere two parts are there. First try to understand. Next one. Observe here. This is I, this is C. Two parts, na? But C may be pointer variable. C is a pointer variable. I is an integer variable. Everywhere two parts. Everywhere two parts. Everywhere two parts. Everywhere two parts. Let us assume that, right? You know very well, integer is 2 bytes. Integer is 2 bytes, right? So char pointer is 8 bytes. Total 10 bytes, right? If you do the padding reading, I think it will become 16 bytes. If you do padding 16, actually they are 10 only. If you want, you can write 10 also, you can write 16 bytes also after padding. Let us assume that 16 bytes. Padding also included. Padding also included. See everyone, it is 1000. Because of everyone is 16 bytes, 1016, 1032, 1048. So I think 16 bytes. I think what is the next one? Is it 60? 16, 32, 48, plus one more 16. How much? 64. Verify. Everyone 16, 16, 16. 60 is table. Indirectly, directly 16th table. Indirectly, directly 16th table. If you want, you can write the 10, 10, 10, 10 also without padding. With padding, that's 16 bytes. With padding, 16 bytes. Okay, fine. Now let me see inside what we remember here integer is expected. I place integer is expected. C place character pointer expected. Character pointer expected. Character pointer expected, not character pointer. Means address. If I go to that address, I need a character. Now see this one. I think first place 5, second place I am giving 2000. If I go to 2000, if I go to 2000, there is a character. Assume it is 2000. Right? Fine. Next one, in the similar way, here integer is expected, here character address expected. If I go to 3000, there is a character. See. Afterwards, what is there? I don't care. See, inside 3000, there is a character. That's the reason 3000 became a character pointer. Further, maybe some more people. In the memory, there are so many people. Right? Next one. It is 6. It is 4,000. It may be 4,000. It is 8, right? Then it's going to be 5,000. And it's going to be 7. It is going to be 6,000. Let me know if I done anything wrong. Is it okay till now? Is it okay till now? Hello? Hello, bro? Is it okay till now? Right? Until now, everything is fine. Now, before going, just I will ask. I'm just asking. Only for namesake, I'm asking. On this array, if you see on the screen, how many arrays are there? Can you help me? How many arrays are there? To proceed further, I want to know how many arrays are there. So one array is ST. One array is ST, and one more thing, if you observe, I think everyone know, see, right? Continuously, if you store same people, that is also array. So become also array. Better also array, Jengil also array, ancestor also array, brother also array. I think there are 5 people plus 1, total 6. So one array having a name ST, main array having a name ST, but other people don't have name, but you have base address. So first person ST having array name. First person ST having array name. So I think remaining 5 people, if you see, there is no name, but I have base address. Okay, I think this is absolutely fine. Until now, everyone is comfortable. Array name means base address. Can anyone guess? If I say print ST, what will print? If I ask you print ST, what will print? And one more thing I want to say to you. Can you see this one? Table required. Priority table required. Let's go there. Priority table required. Let's go there. So I think maybe 73 or 74. I don't know. Important tables for BFCS. Okay. This table required. Please be careful. This is the table. Operator precedence and associativity. This table may be required. I opened also. Be careful. Whenever required, will come. I think everything is ready. Right. Can you help now? Print ST. What will print? I'm expecting answer. Print ST. What will print? Make it fast. Print ST. What will print? Everyone make it fast, yeah. Print ST, what will print? This much time. So I want answer. What is that? Print ST, what will print? Make it fast. Can you say what is that? Diagram also there. Yeah, I think Anjali given 1,000. Are Bhaiya, array name, yeah. Array name means outside. Yeah. How can you come inside? I know very well this will happen. That is the reason I asked you. Array name means base address. So can you help me? Print ST, what will print? Print ST, what will print now? I written diagram also, yeah. Bhaiya. Can you help me? What will print? Everyone. See, it is a structure array, like integer array, structure array. Everyone can have array, na? Everyone can. The only thing is inside group is there. The only thing is inside group is there. Assume it is integer array. Integer array means one person there. Structure array, two people are there. It is array. It is simply array. Don't confuse. It is array. The only thing is if you go inside. What is the difference between integer array, structure array, integer array? If you go inside one person, structure array. If you go inside many people. I'm repeating once again. Structure array. If you go inside many people. Integer array, if you go inside one person, see, if you go inside integer array, one person there, but structure array, group is there. This is the only thing. If group is there, if you go inside group is there, how to access? Using dot. If group is there, how to access? Using dot. Right? Fine. Perfect. Perfect now. Everyone is absolutely fine. Everyone is absolutely fine. Until now, everyone is fine. So array name means base address. As usual, as it is, whatever you done for a normal integer array, same thing here. And one more thing. Is 1D array or 2D array? Is it 1D array or 2D array? Array okay. 1D array or 2D array? Is it 1D array or 2D array? Make it fast. Say, Reddy sir is a drinker. He started the drinking again. Reddy sir is a drinker. He started the drinking again. Say, just right, I am drinker or not. It's none of your business. You just say, is it 2D array or not? Or 1D array. Just say this. Reddy sir is a drinker. So what? I am drinking water. So what? Is it 1D array or 2D array? Make it fast, yaar. Why people not responding? I don't know. Is it 1D or 2D? 1D. In the 1D array, what is plus 1? It's a 1D array. I am very happy. In the 1D array, what is plus 1? Skipping one element. 1D array. In the 1D array, what is the plus 1? Skipping one element means skipping one element is one group here. Here element is group, nothing there. Here element is group, nothing is there. Here element is group, nothing is there. Right? So one group size is 16 bytes plus 1, 16 bytes will increase. 16 byte will increase. Remember everyone. This is a array, 1D array. Right? Array name is ST, means 1000 will be printed. ST plus 1, skipping one element, 1016, including padding 16, nothing is there. Right? Fine. I think everything is fine now. Now listen everyone. I think main program is started. Now main program is started. Everyone observe. Main program is started. Struct test type, one pointer variable you took. Let me use another color. Struct test type, one pointer variable you took. So let's see. Right? His name is, I think I have to use some other color, no other option. I think I'm using the green color. See this one. P is a struct PT type. Struct test type, one pointer variable P I took. He is simply saying that, P simply saying that I want address of struct test. That is the reason I given ST. So ST means, right, array name means base address, 1000 I given. If you want, you can check inside 1000. If you go struct test type data is there. So P contain address of struct test. If I go to inside that 1000, you will find out struct test type data. Right? So I think P itself having its own address. It may be having some other address like 7000. 7000 it is. P having its own address. Remember P is a variable. Variable means inside. P is a variable means inside. Right? ST is a area. I think perfect. Everyone is clear. Variable means inside. Array means outside. Everything is clear. Now listen. P, right? Listen everyone now. P is a struct test type. Struct test type 1% 16 bytes. Remember, if I increment P, wherever you pointing, I think 16 bytes. If I say plus 1, next is 16 bytes. P will increment by 16 bytes. Remember, every one increment is based on where are you pointing. Every one increment is based on where are you pointing. Where are you pointing? Your right. Your increment is based on where are you pointing. What you are thinking. Whatever you think, you will point there. What you are thinking. Are you thinking negative? Negatives only will happen in your life. Are you thinking positive? Positives only will happen in life. I'm repeating once again. Right? What are you thinking? Means where are you pointing? Wherever you are thinking, there only will point out. Right? So where are you pointing? Means what are you thinking? Are you thinking negative? Right? Negative only will grow. Are you thinking positive? Positive only will grow. So now see this one. P pointing to 1000 where 16 bytes are there. If I say plus 1, next to 16 bytes. If I say plus 1, next to 16 bytes. Be careful. I think in the ST also same way. P also same because both are same type. ST also struct test type. P also struct test type. But ST is a array. P is a pointer variable. Everything is ready. Variable means inside. P means 1000. ST means outside. All the basics I made it clear. Now listen. Now see this one. This is completed. This is completed. Okay. Now see this one. P is equal to P plus 1. I think he's updating. It's a 1016. So P is not here. P here. P updated. P is equal to P plus 1. Wherever he is pointing, he should point to next. So P contain now 1016. That is also okay. Now understand. Understand everyone. Can you see the third line? Can you see the third line one time? Plus P arrow C. Plus P arrow C. Everyone observe. Plus P arrow C. Everyone have to understand. Plus P arrow C. So carefully understand. Carefully understand. So you have to come from left hand side. Every expression, you cannot go random places. Come from left hand side. Wherever first operand, stop there. P is 1016. P is 1016. P is 1016. Please try to understand. P is 1016. See what happened. P is 1016. Right? P purpose, left person also plus fighting, right person arrow also fighting. You know very well. Arrow having highest priority. If you have doubt, I opened also. See this. Array is there in the first place. See. Sorry. Bracket is there. Arrow is there in the first place. Arrow is there in the first place. Am I right? Plus is there in the second place. Plus is there in the second place. Arrow is there in the first place. It is right. This is from one standard book. This is from one standard book. Right. This is from one standard book. Right. Please be careful. Arrow is in the first row. Plus is there in the second row. Please understand. Please understand. Right. I think everyone is fine now. Arrow should be done first. Remember, arrow should be done. So P arrow C will be done. But do you believe or not? What is PROC? This is the shortcut. This is the shortcut. What is the actual PROC? Is nothing but star P dot C. Yesterday I explained. PROC means, remember, arrow symbol means it is a shortcut. It is actually shortcut. But what is the actual star? One star will be there, one bracket will be there, one dot will be there. One star will be there, one bracket will be there, one dot will be there. Please be careful. Please be careful. If you don't keep bracket, P will go with dot because dot is highest priority. If you don't keep the bracket, P will go with the C. P will go with the dot because dot is highest priority. So you have to keep bracket also. So whenever you see PROC, right, one star will come for the P first person. Star will come, bracket, afterwards dot C. Please be careful. So anyhow, there is a plus. Outside plus is there. Outside plus is there. Remember, this is first. Then plus. PROC place star P dot C came. Outside left hand side plus is there. I kept plus. Now observe clearly. P is 1016. What is star 1016? Listen everyone now. P is 1016. What is star 1016? You went inside. Listen. Whenever you went inside structure, there is a group. As soon as you enter inside, immediately I and C is asking whom you are calling. Star 1016. Inside you went. Then I and C is asking whom you are calling. Inside structure, if you go, you have to say dot. Right? Dot I, dot C you select. Dot C I selected. Dot C means I came here. Now I have 3000. Remember, this entire thing is 3000. Means I am at here now. Please be careful. Now, wherever you are, for that there is a plus plus. Remember, I am at here means I am pointing 3000. When I say plus plus, 3001 it is. This became 3001. Please be careful. So this also completed. Third line also completed. See the fourth line. I think printf is important to us. See the fourth line. Everyone see some game. So as usual. Understand this. As usual. P plus plus arrow C. Now my question to all the people. P purpose, how many people are fighting? Fourth line, please understand. Fourth line, please try to understand. P plus plus arrow C. I will write here. Fourth one. P plus plus arrow C. Can you say P purpose, how many people are fighting? P plus plus arrow C. P purpose, how many people are fighting? Make it fast. One person. Neighbor is only one neighbor. Immediate neighbor is only one. Immediate neighbor is only one. P plus plus arrow C. Right? Immediate neighbor is only one. So you have to do P plus plus first. So remember, as of now, P 1016. So remember, it's a post incrementation. 1016 only. You done incrementation, but it don't increment now. It will increment afterwards. 1016 only. Now this sentence became 1016 arrow C, which is nothing but star 1016 dot C. Star 1016 means go inside 1016, right? Afterwards dot C. Dot C means here, which is 3001. So this entire story became 3001. So remember at the end of this, you have 3001. 3001 onwards print the string. 3001 onwards print the string. Right? Just wait 1 minute. Someone is knocking the door. Not someone, madam is knocking the door. You know very well, madam knocking door, you don't lift phone, you know the consequences. Food also will not be there. So you have perfect now. So 3001 onwards everything will print. 3001 onwards everything will print. What is that one? ETTER will be printed. 3001 onwards ETTER will be printed. Thank you so much everyone. So the output of this one is ETTER. Perfect. So fourth one successfully completed. But in that happiness, the problem with the students is, in that happiness, one pending thing you done. See, P plus plus you done. You may forget. Because they are very happy. Students are very happy. They got some output. ETTER. Yeah, I got ETTER. Yeah. But by yeah, it is pending. By yeah. P you done P plus plus. It will increment now. It became 1032. Remember, there is no line like this. Whatever address you give, He will point there. Whatever address you give, it will point there. There is no arrow line like that. If you keep in the pointer 1032, it will point to 1032. If you keep in the in the pointer 1016, it will point. Whatever address you give, it will point there. So now P became 1032. Okay, perfect. Now can you come to the fifth line? Can you come to the fifth line? See the fifth line. Printf percentage C star plus plus P arrow C. I think it is the fifth line. I will write properly. I will explain here. I will write properly. So fifth line. Fifth line. See this one. Star plus plus P arrow C. It is the fifth line. We understand everyone. Now P became 1032. Right? So start from left hand side. Start from wherever operand stop. Start from left hand side. Start from left hand side wherever operand stop. For the P purpose, plus plus also, arrow also. Arrow is the winner. So this will become star P dot C. This will become. So outside people are same. Plus plus is there, star is there. Afterwards we will see. So P arrow, right? P arrow C become star P dot C. What is the P? 1032. 1032. Go inside. Star means go inside. 1032 inside if you go. I also there, C also there. As soon as you enter, immediately they both are asking whom you are calling. I or C. I think it is C. So C. I am at here. Remember, I am at here. But wherever you are, for that plus plus C. Wherever you are, for that plus plus. So this is going to be now, you are at 4000. You are at 4000. 4000 plus plus. Remember, it is also character pointer. It will goes to 4001. It is not here. It is here. 4001. Okay. Plus plus you done. That is also okay. After done plus plus, it became 4001. It became 4001. I am very happy. For that star operator, the value inside 4001. Remember star. Star means one character. One character. Star 4001. Star 4001. I think you will be printed. Arey bhaiya, after incrementation character. First increment, it became 4001. Because if you observe clearly, there is a plus plus first. First increment. Then when you increment, it became 4001 star. The value inside 4001 jungle. The value inside 4001, right? The value inside 4001, one character U. Because star also E done. Suppose star not there, from here onwards print, I will print on. Star, you went inside the 4001. Only U. So this will print only U. Right? Okay. I think fifth line also successfully completed. Can you see the sixth line? Everyone observe. He played so many games. This person, the person who given this problem, he played so many games. It's one of the gate problem. I request everyone, that is the reason, do all PYQs. It's my sincere advice to all the people. Do all PYQs. Right? So this is one of the gate problem. PYQs you are okay means your gate preparation okay. Now can you see what is the sixth line here? So see this one. P purpose only one person fighting, bracket. P immediate neighbor is bracket. P of 0. Remember, P of 0 is a shortcut. Remember, P of 0 is shortcut. What is the P of 0? Star P plus 0. P of 0 means star P plus 0. Because P is not array, he will blame you. See this one. P is not array. P is a pointer variable. It is not array. P is not array. P is a pointer variable. If it's a pointer variable, how he can use the right bracket array format? How he can use to blame you? To blame you, he will use. It's like a blaming. One student called me and is asking, sir, P is not array, na? How you can use like this? You are a blind person. You are unable to see. What can I do? One student called and he said, Reddy sir, mera dimag kharab. I said, what happened? In this problem, P is not array, na? How he can use array? Array buffoon. Array buffoon. He may use meaning. Can you see the meaning? Na? What is the meaning? Star p plus 0. Remember, every pointer they can play in the form of array format. If it is a pointer, he can play. See, array format will be played with the array person. Array person playing array format, no issue. But pointer person also play array format. Pointer person also can play array format. How? P of 0 means what? Star p plus 0. What is P as of now? 1032. P plus 0, 1032. What is star 1032? You are inside. You are inside. When you go inside, two people are there. I also there, C also there. What you selected? He selected I. Afterwards, after going inside 1032, I and C both are fighting. But you want I. You want I. So inside 1032, I is 6. Inside 1032, I is 6. 6 will be printed. 6 will be printed. I think it is an interesting line. It is an interesting line. 6th one will be printed 6. Breaking news. Breaking news. 6th one printed 6. 6th printf statement is 6 printed. Breaking news. Array Bharadwaj, it is a breaking news. 6th printf statement printed 6 only. It is a breaking news. Ankit Bhaiya, it is a breaking news. 6th one printed 6 only. Oh, fine, perfect, perfect, perfect. Now let's see the 7th one. Let's see the 7th one. Printf percentage yes, P arrow C. Once again, right? There is no arrow. It is a shortcut. There is no arrow. It is a shortcut. But what is the actual? Can you see this? 7. P arrow C. That means star P dot C. Right, star P dot C. What is the P? I think not incremented 1032. Inside 1032 you go. Inside 1032 you go. Right, I went inside 1032. I went. Okay, then I there, C there. So take the C. I there, C there. Take the C. Take the C. C means I think the previously incremented 4001. It became 4001. 4001 onwards, everything will be printed. What is that one? Angle. What nonsense it is. Angle. Actually, it is a jangle. Actually, it is a jangle. So, J gone. It became angle. Angle. It became angle. Perfect. Perfect. So, outputs, if you see, first output is printed. 5th one will be printed. I think 4th one is printed. Yeah. 4th one, right? First printf is printed eta. Right? So 5th one will be printed U. 6th one printed 6. 7th one will be printed angle. So I think there are some options also there. Some option. So many tempting options are there. For this problem, so many tempting options. See, option A. So many tempting options. Option A. Jangle. Small mistake you do, you will give wrong answer. N8. NCSTOR. That's option A. Option B. ITER U6 angle. Option C. So many tempting options. If you try your own, you know the pain of this problem. Because I explained, you are looking easy. Right? When you try yourself, you will stuck many places. I also stuck at many places. While doing first time. I know the pain of this problem. ITER U8 NCSTOR. If you do small mistake also, one option, right? Small mistake also, one option will match. I think answer is B. Answer is B. Right? Fine. Perfect. Okay, I think most of the things will done. Now be careful now. Most of the things will done. There is one topic is coming. That topic is typecasting. That topic is called typecasting. If you find any difficult problem from now onwards, if you find any difficult problem, yet anywhere if you find any difficult problem, any problem of C, if you find in the group, I request everyone, if you find any difficult problem, Any difficult problem of C or whatever subjects you completed, if you find anything, post in the group. It's my humble request. You find something interesting, post in the group. Ask, challenge them. Can anyone give answer? Even though you know answer, please challenge them. Then you will get to know how many people are there. How many people are there like you? How many people are there like you? You will find out. If you find that any very interesting problem, please post it. Suppose if you find somewhere you don't know the answer, please post it. I think you can start that PYQ. Almost we done it. Every PYQ mostly you can solve. However, few problems will stop you. You can post in the group. However, right, I started asking group experience also. Your doubts are solving or not. I don't know how many people are responded. Right, group experience also I'm asking. So if at all, right, if a group performance is not perfect, then I will shout on those people who are doing the interview. Those people who are handling the questions, I will shout on them. I asked the interview experience, right? Sorry, I asked the group experience also. Let me check how much people are given. Few days back I given. Yeah, I think it looks like mostly satisfied and excellent, like that people are saying. Yeah, I request everyone I request, use the group. Any nice problem, post. Nice problem, post. In the group, nice problem. You find somewhere nice problem, please post it. Somewhere you find out the nice problem, please post it. And some people are asking, sir, where to practice? Right? Some people are asking, sir, I done the C programming and all. C program completed. Where I will practice? Can you go here? Sir, where the C programming questions? So I completed one subject. Where I will practice, sir? Ready, sir? I completed one subject. Where I will practice? Just go to here, EPT free resources. Go there. EPT free resources, you go see. There is a verified questions. Right? So I think you can sign in. Then you will find out verified questions asked. Then you will go to here. Abhinav AIR1. He is the one who made this. All the good questions are there. Please take care. Now see this. Right? Which subject? C programming. Go there. C programming. This is 235 questions are there. 235 good questions are there. Please practice. 235 good questions are there. Please practice. 235 good questions are there. Please practice. Right? This is the thing. As soon as the subject over, please practice it. Out of them, few may be PYQs also. See, few may be PYQs. PYQs also included here. Some may be outside. See, this may be the outside. Some may be outside, some may be inside. But all good questions are there. PYQs also unnecessary things we remove. Suppose you completed algorithm. Right? Algorithm 446 questions are there. Please practice. All the good questions we kept. Any subject you completed, I request you please practice from here. Next one, discrete mathematics completed, aptitude completed, operating system, whichever subject you completed, please practice from here. Any doubt is there? If you think that answer is not matching, if you think like that, so you can ask in the group. I am getting answer is this. What is your people answer? Please let us know. Right? So fine. I think this is the thing. So let's come back to our story. Right? So structures also we done. Now before going to the next topic, typecasting, I think small thing I have to announce. New batch, about the new batch. Just give me 2 minutes. So these are the GATE 2026 toppers. So and one more interesting thing about all these toppers is most of the people cracked the GATE examination in 6 to 12 months. EPT goal is like this. See, whatever is our goal, accordingly students will go 6 to 12 months. 6 to 12 months are more than enough to crack the GATE exam. 6 to 12 months. Minimum 6 months required, maximum maybe 12 months are more than enough. If you plan properly. Subject over, do the PYQs. Subject over, do practice questions. So 5th rank, 7th rank, these are the people done. Most probably like that. I'm expecting you also next year. I'm expecting you also next year. Right? If you are liking EPT classes, you can inform to your friends. If you are liking EPT classes, you can inform to your friends. So in your profile, there is an option like referral code. That code you can share to your friends. If they use it, you will get the 20% cashback. And one more thing is, right, I think now offer it changed, right, 50%. On all combo courses, 70%, right, on the all courses, 50%. All courses 50, combo courses 70. Next one, if you selected for any mock interview, we are going to conduct a mock interview, you can utilize it. If you selected for any interview, either PSU or right MNC company or IITs, anywhere if you selected, for any interview, if you selected, just inform to us, we will conduct the mock interview with the experts. Right, next. So C programming is free, it is going on now, it is free, you can utilize fully, everything. Most probably every question will come from this course only. Everything I covered. One point also I didn't miss out, everything I covered. More, if you want, you can verify after GATE exam is over, if you come and check. All the things are whatever I taught from this only it came. It don't come, one question also will not come out of this. IIIT Hyderabad, mock tests are going on, please utilize. 6 mock tests are free, you can utilize. And you can go for combo courses, you can go for whatever course you want, you can select. So every Saturday at 8 o'clock, there is a mentorship session. I hope you will utilize it. Mentorship session, don't miss it. Every weekend we are giving targets also. Every month also we are giving targets. I request everyone, don't miss it. These are the verified questions, 6,000, PYQs 3,000, AIR1 notes also there, free doubt solving also there. Please go to doubt solving group, doubt solving also there, right? And one more thing is, let me check this. If anyone not joined the doubt solving group, please go to free resources. You will find out here doubt solving group also. You just click on that, you will go to doubt solving group. Previous year questions if you want to go here. Toppers, AIR1 notes, Abhinav notes if you want, you can go here. Verified questions if you want, you can go here. Yeah, perfect. Now come to next story. So in EPT, not only GATE, placements also will take care. So these are our placement people. I want to see you also in big companies, you will also select. DS is Super 50 going on, 50 best interview questions. Those people who are interested, they can join. Now come here. Now come to the actual topic of today's class. Right up? Typecasting. Please be careful, everyone. Typecasting is the next topic. Yeah. Go ahead. It's a very interesting topic. Right? Typecasting. Typecasting is nothing but converting from one type to another type. Right? Let me write one by one. First one. First point, note or whatever you can call it as note. Converting from one type to another type is known as typecasting. Converting from one type to another type. Is known as typecasting. Second one, why are you doing? Right? Why are you doing? I will give you some small idea. See, there is a rule there. See this one, there is a rule there. The rule is saying that if you want to perform any operation between two variables, both should be same type. Rule is, let me write the rule. It is a programming language rule. If you want to perform, any operation between two variables, then they both should belong to same type. If you want to perform any operation between two variables, then they both should belong to same type. They both should belong to same type. Try to understand. This is the rule. Some people are asking, sir, this rule not satisfied. What we will do? Suppose I am giving example. See the example. Examples. If you want to see this one, 10 plus, assume that A10 plus 20.5, it is B. You want to perform addition between these two people, but both are not same type. You want to perform operation between these two people, right? Both are not same type. Suppose both are the same type, no issue at all. See here, no issue. A is 10, B is 20. No issue at all because both are same type. No issue at all. You want to perform some operation between two variables. Both should be same type. So next one more. A is 10.5, B is 20.5. You want to perform addition. No issue at all. But here issue there. See, here issue there. Both are not same type. Here issue there. So what will happen is, I think float is bigger size. It is a 2 byte, it is a 4 byte. Whichever is the bigger size, write as it is. No change. But smaller one, right? Smaller one. See, the one which is stored in the small memory, if you store in the big memory, nothing you lose. The one which is stored, right, which is staying in the 2 BHK, if you shift him to 4 BHK, no issue at all. The person who is staying in the 4 BHK, you shift it to 2 BHK, there is a issue. You will say space problem. We are losing something. So remember, so 20.5 is because of float is 4 bytes, integer is 2 bytes. So smaller one can be shifted. No issue at all. Smaller one shift. How this is called typecasting. 2 bytes person you stored in 4 bytes. 4 bytes person, 4 bytes you stored nothing. 2 bytes person you stored in 4 bytes. Oh, 2 bytes person, 4 bytes I stored. So this is called typecasting. Some people are asking how, what is the terminology? Can you see this one? This is the terminology. Listen everyone, this is A, which is the integer. A is 10, which is integer. You want to convert into float, na? This is the way. You have to write float. This is called typecasting. A10, which is the integer. When you do this, as of now, in 2 bytes it is stored. Now after this, it will store in 4 bytes. Then it became in 4 bytes. In 4 bytes, it became 10.0 in 4 bytes. Before conversion, right? Before conversion, in the 2 bytes, 10 is there. After conversion, after this code, it will convert into 4 bytes. This is also A. This is also A. This is called typecasting. This is the code for this. Important thing is you are not updating A. See, if you don't update A, you don't update. See, are you storing finally A is equal to, then it will update. Otherwise, you don't update. Be careful about small things. Simply, I took the A10, which is integer 2 bytes. I convert into float. Then what happened? It will store in 4 bytes. Previously, it is a 10, 2 bytes. It is now 10.0, it is in 4 bytes. Remember, A will not update because you are not updated in the code. Code only will decide is it updating or not. In the code you are not updating, here also A will not update, but you will get the value 10.0. It may not be E. because you are not updated. I hope, are you comfortable till here? Some people are asking, why are you converting? Why are you converting? This is the rule. We have to follow rule. If you want to perform any operation between two variable, then they both should belong to same type. Then they both should belong to same type. Same type, no issue. Same type, no issue. Different type issue there. There may be a problem here. Then what you have to do is convert. Then what you have to do is convert. Which one you want to convert? You convert whatever way you want. So some people are asking, sir, float. This is a float, this is int, right? This is the int, this is the float. So why are you converting int to float? Why don't you do float to int? You can do 4 bytes you are trying to store in 2 bytes. You may lose data. So if you try to convert this one, right? If you try to convert this one, you may lose data. You may lose data, right? Because anything can be done. Anything can be done. If your requirement is float to int, you can do. When sometimes what happened is when you return something of different types, so what compiler will do is compiler will convert its own way, right? Without affecting. What does that mean? Smaller one you will store in the bigger one. Compiler sometimes will convert. Whenever you return something where different types are there, compiler what it will do is it will convert without changing the data. Simply smaller one will store in the bigger one. This is called as implicit typecasting. Someone is saying, sir, one confusion. There is also type promotion and smaller type promoted to bigger one by compiler. Confused between promotion and casting, right? There is nothing like that. So implicit typecasting, explicit typecasting. See, implicit, explicit. Implicit typecasting, explicit typecasting. Implicit typecasting. Implicit means no problem. No problem. That is called as implicit typecasting. Some problem. That is called explicit typecasting. What is the meaning? No problem. Suppose is 2 bytes data you stored in 4 bytes. You don't lose anything. 2 bytes data if I store in 4 bytes, you don't lose anything. So what happened is sometimes compiler will do. Implicit type conversion means typecasting means compiler will do. Whenever no issue, compiler will do. Suppose some issue there means you are losing data, but you are losing data. What is the meaning? 4 bytes data you are trying to store in 2 bytes. Guarantee you will lose. You will lose the data here. You will lose it. You will lose data. But user want it. So user can do it. User will do. You are losing data means user saying that I am losing data, I am okay. I don't have any issue. But convert. Right? User is saying that convert. Then compiler will say error message saying that you will lose data. Then user will say, okay, no issue, convert. So forcefully if you do, that is called explicit typecasting. That is normally done by the users with the help of code. User will do using code. You will write code using code. Compiler, whenever, see this one, rule is saying that both should be same type, but you return both different. What compiler will do is, without affecting, without losing data, he will convert. That is called implicit typecasting. Implicit typecasting means whenever there is a chance, conversion possible without losing data, compiler will do. That is called implicit typecasting. Whenever there is a chance that losing data, you are losing data, compiler will do error message saying that you are losing data. Be careful. That is the meaning of error or warning. That is the meaning. You are losing something. Please check once again. If you say, okay, I am ready to lose, you write the code. That is called explicit typecasting. Okay, fine. So you will get to know within few minutes clear clarity. Within few minutes you will get the clear clarity. Right? Now listen. So actually data there is nothing is there. Data there is nothing. See, data there is nothing. Can you see this one time? Integer 2 bytes. char 1 byte. Let us assume. However, system to system it will change. Float 4 bytes. Let us assume. This is assumed that A, this is assumed B, this is assumed C. A, B, C. A, B, C. Now see what happened. A, B, C. You done something like this. You done something like this. Understand everyone. You done something like this. A is equal to C. It is 2 bytes. It is 1 byte. A is an integer. A is an integer. C is a character. You written A is equal to C. Please help me. Please help me. Everyone observe. Everyone observe. A is equal to C. The people who are participating in this operation assignment, are they same type? First question. Concentrate, your target is this only. So in my opinion, typecasting just started now. I written something. Now you will get clarity. From now onwards, be careful. From now onwards, be careful. From now onwards, be careful. I am doing assignment operation. Everyone careful from now onwards. Typecasting just started now. Typecasting just started now. Now please give answer. Please give answer. The people who are participating in this assignment operator, are they same type or different type? Please give answer. The people whom you are doing the operation now, are they belongs to same type or different type? According to rule, both should be same type. According to rule, both should be same type. Are they same type or different type? Different type. Different type. As per the rule, both should be same type or not? As per the rule, both should be same type or not? You written unknowingly, knowingly. You written unknowingly, knowingly. Unknowingly, knowingly, you written one operation. Unfortunately, they both are different types. Unfortunately, they both are different types. So, according to rule, you are violated. Then what compiler will do is, see this one. Compiler will do like this one. 1 byte data is storing in 2 byte. Compiler got to know. 1 byte data is storing in 2 byte. No issue. Compiler don't want to disturb the user every time. It is actually, you are violating the rule. You are violating the rule. Both should be same type. Both should be same type. You are violating the rule. Compiler got to know. While compilation is going on, compiler got to know. Oh, my user is violating rule. But to be frank, 1 byte is storing in 2 bytes. Nothing you will lose. So what compiler will do is, see this one. Compiler got to know you are violating rule, but every time you don't give error. If every time giving error, then why compiler? Compiler should solve some problems. So what compiler will do is, he got to know, no problem also. If you store 1 byte data in 2 bytes, what do you lose? So what he will do is, compiler itself, it will go inside your code. It will go inside your code. Compiler got to know there is a rule violation, but compiler got to know there is no issue also. 1 byte you are storing in 2 byte, no issue. Then what compiler will do? A is equal to C, which is the character, he will write, convert into int. Right, this C. C is actually 1 byte. You convert into integer, it became 2 bytes. 2 bytes you are storing in 2 bytes, no issue. Now rule is satisfied. Interesting thing is rule satisfied. But who done this? This is called code. This is the code. This code user not written, compiler written. This code is written by compiler. Whenever no issue, you don't want to trouble the user. This code is written by compiler. This is called implicit typecasting. This is called implicit typecasting. Who written that code? Compiler. You may say that who is the compiler to write the code? And one more thing is, it is not visible in your code also. It is not visible. So he written in himself, right? He have one copy. He will be right. He himself having that particular one. So everything he cannot disturb the user. So there is a way both should be same type. Both should be same type, but you are not using both are same type. So rule violation. Every time if I give, if it is a rule violation or a compiler, you convert, na? So small issues he will convert. See, I think he got to know, right? Rule violation, but actually no mistake going on. So he will convert himself. Remember, either you should convert or compiler should convert. If big problem, compiler cannot convert. Let's see. What is the big problem? Can you see this scenario? Can you see this scenario one time? Everyone observe. Can you see this scenario one time? See this. B is equal to C. B is actually 1 byte. C is actually 4 bytes. You done like this. When you done like this, I think you are storing the float in char. So it's a rule violation because both are not same type. Rule violation. Compiler got to know rule violation. Now listen. Compiler got to know rule violation. Everyone has observed. Compiler got to know it is the rule violation, and compiler got to know one more thing also. Compiler got to know two things from this. Whatever you written, compiler got to know two things. One thing is rule violation. Rule is gone. You are not satisfied rule. One more thing you see. 4 bytes you are storing in 1 byte. 4 bytes you are storing in 1 byte. You will lose data also. You are losing data also. Losing data. I think definitely whenever losing data, compiler cannot do by himself. Every time people will not help. Small issues people will help. Small issues. If anyone asks me, sir, that some people calling me and asking, sir, 2 companies are there, which one I have to join? Right? I don't want to take risk. I will say safe. I will simply say through experience, you are getting 2 offers. You are an excellent person. You are most talented. Thank you so much for asking. To me, it looked like both are very good companies. Can you do research one time? Can you say what are the positive points of this company? What are the positive points of this company? Can you have one table? Please come to the table so that I can conclude. Next one afterwards, then again I will ask them what are the salaries, what are the rules, regulation, and one more. Still, if I have doubt, I will ask him, can you find out in the LinkedIn someone who is working, right, that company and this company, can you ask their feedback also? So like that, how many employees are there? What I mean to say is, whenever, right, if something can be done by myself without having anything, directly I will say. Suppose it will create some serious issue in the life. So I will do it in the similar way. See this one. Compiler got to know 2 things. From this code, compiler got to know 2 things. What is the one thing? Rule violation is done. And what is the one more? Losing data. So what compiler is intelligent person? He don't convert. He will simply give error. He will inform to user, right? Type mismatch. He will give error. Here error is not there. He converted. See this one. He converted. He written the code also. Compiler. This code is written by compiler. This code written by compiler. This is called implicit type. Some you may say that how he can write the code in my code. Who is he to change? Because no problem. Because no issue. So he written the code. And one more thing is because of rule violation. No issue means you don't lose anything. And one more thing is because of rule violation, he will convert. First of all, why are you converting? Rule violation. And one more, why are you writing in my code, your own code? Because no issue. See, if no issue, I don't have any problem. Whether you are writing or not, I don't care. If at all no issue, now here issue. You got to know from this rule violation also there, losing data also there. Losing data. Compiler will simply say, I cannot do type conversion. Error means what? I cannot do type conversion. Compiler saying, I cannot do type conversion. Because you are losing something. If I do, you may blame me. I cannot do type conversion. Right? You may lose data, you may blame me afterwards. So then some people are asking, then what should I do? User should do. Then listen. Right? User got to know, type mismatch. Compiler also saying, I cannot do. Error means I cannot do. Compiler also saying, I cannot do. Okay, there is a serious issue. But I want this one. Then what the user will do is, listen, user is doing, because of compiler saying that some error. Compiler also saying that be careful, there is some data loss is there, that is the reason I am not doing, you be careful. Now user writing code, see this one, user writing code. What user write? You want this only. So B, which is going to be 1 byte. So I think, right? So you want 1 byte means char, no? Convert into char type. This is C, which is 4 bytes. Then when you do this, out of these 4 bytes, 1 byte only taken. First byte, whatever is there, that byte taken. It's a 4 bytes data. Let us assume that in these 4 bytes, let us assume that in these 4 bytes, right, very good data is there, right? So he will take only this byte. You will take only this byte. He will give. So you will lose this much. This much you lose because of this line. Because of this line, convert into character. That is the reason you are losing data. 4 bytes if you store in 2 byte, 1 byte, guarantee will lose. User written this code. See, this code is written by whom? User writing this code or user written this code. After seeing that error, user went to the code and he written. Initially, user written this code. After seeing that error, user written this code. Or user wrote this code. Now no error. Now compiler will say few things. What is the answer? Now both are same type. Compiler will check now. Again you are after every change of the code, you have to compile again. Now it will check. Both types are same. Both types are same. So rule satisfied. You may be losing data. So second point. See the second point. You are losing data, but you this is the approval. You approve. You approve to the compiler. I am ready to lose data. Written code means what? You approve. So you are losing, right? With approval, you are losing data. It's okay. Without approval, losing is a bad idea. With approval, you are losing data. This is called as, remember, finally, this is called explicit typecasting, not implicit, explicit. Explicit typecasting. Fine. Is it okay? So serious issue. Listen, very important thing. Very important thing. Please listen. See this one. Same code. Code is same. Who is writing this code? Code is same. See, you want to convert into character, carry you written. You want to convert into integer, so int you write. Code is same. Whatever you want, you will write. But code is same. Who written that code? Who written this code? First of all, why are you writing the code? Conversion. Why are you converting? Rule is saying both should be same type. Both are not same type. So to convert, I am writing the code. But who is writing? Compiler. When compiler will write, you got to know some problem, but no losing data is there. Compiler will write. That is called implicit typecasting. So next one, right? So rules, right? Both are not same type. So I have to convert. But while converting, you may lose data. Compiler will say I cannot do because there is some data losing. So user saying that okay, let me write the code. Because you are afraid of writing code, because if something lose, I may blame compiler. Compiler saying, I don't want to take a headache. So you please take care yourself. You written this code. So this means you approve. So now both the types are same. Next one. With approval, you are losing data. That's okay. With approval, losing is okay. Approval means what? You written the code also. This is called explicit typecasting. Okay. And if you are comfortable, I can move to the next one. Are you okay? Can we move to next? Let me know. Everything we done. Let me know this. Hello? Can we move now? Can we move now? Everyone say. Just if I give few examples, everything is okay. I am giving some gate problems. Can I move? Implicit, explicit. In both the places, code is there. In both the places, conversion there. But one place you lose data, another place you don't lose. Don't lose. Compiler will say, oh, it will trouble the user. Let me do by myself. Losing data, oh, it will trouble. So let me inform the user by giving error. You will inform, user will write the code correspondingly. So automatically these things will happen. Now come to the next one. So that is called typecasting and all. Now typecasting in pointer. Right now, this is the thing which required. This is the thing which required. Right now, from now onwards, be careful. Typecasting in pointer. This is the area which required. You can expect some questions from here. Typecasting. Typecasting in pointers. Typecasting in pointers or with pointers, whatever it is. Typecasting with pointers. Be careful. From now onwards, be careful. From now onwards, be careful. Everyone try to understand. One problem I am giving. This problem will give you much clarity. After this, you feel more comfortable. After this problem, you feel more comfortable. Right? Let's see. Main. It's a very nice problem. Try to understand. Main. Int. Main int. A is equal to 300. Char star B is equal to this problem will give much clarity to you. This problem will give much clarity. Someone is saying that why compiler allow int x is equal to 10.5 and remove 5 bytes. Why compiler will allow 10.5 and remove by 5 bytes. So can you write the program and let me know? Ankit, you write the program and let me know. Okay, you write the program and let me know. Right, after class is over, you check. Right, don't check now. After class over, you check. Tomorrow also you can ask it. First to try by yourself, then you can ask me. Right, now can you concentrate on this? Everything is ready. Everything is ready. Everything is ready. Can you concentrate on this? Very, very interesting problem. If you don't listen, you may lose some valuable things. Please understand. Very, very interesting story. Very, very interesting story. Can you see this? Let us assume that. So I am writing this problem. Carefully. Assume carefully. Assume integer 4 bytes. This code, whatever code I written, by assume integer 4 bytes. Assume integer 4 bytes. Right? With that intention, I written this. Character is 1 byte only. Char 1 byte only. Assume integer is 4 bytes, char is 1 byte. This is the assumption. Right? Be careful. With that assumption, I written this program. Now, everyone try to understand. So, int a is equal to 300. Understand? Int a is equal to 300. So, this 300 will store inside a. This 300 will store inside a in 4 bytes because integer I am assuming 4 bytes. If you want, you can assume 2 bytes also. Then I have to delete few things. You want 2 bytes only? Sir, why suddenly you are changing to 4 bytes and all? Let's write this. If that is the case, that is the case, 2 bytes only take. You don't want to 4 bytes, you can take these ones. Both are okay, there is no objection. Okay. Now see, observe now, both are 2 bytes. This is 2 bytes, character is 1 byte. Now everyone observe now. So now 300 will store in 2 bytes. Now 300 will store in 2 bytes. Try to understand. Now 300 will store in 2 bytes. Right? Fine. How it is storing? But remember, inside a computer, everything inside the computer, everything in the form of zeros and ones. So what you do is, inside A means inside 2 bytes, 300 how it is storing. Convert into binary number first. Convert into binary number. See how I am converting? 300 you want to convert into binary number. What you do is, what is the closest powers of 2? I think 2 power 8. 256. So remaining, if you observe, right, actually 300 binary number I want. Just see, closest powers of 2 without crossing, 2 power 8, 256. Remaining is 44. 44 closest powers of 2, 2 power 5, 32. 2 power 5, 32. So from the 44, if you remove 32, remaining is 12. I think 12, I can write binary number directly, 1100. 1100 is 12. So if you add all of them, please check, it is a 300. 2 power 8, 256, remaining is 44. So 44 closest powers of 2, I think 2 power 5, 32, remaining is 12. 12 I know binary number, directly I written. Now see the next one. See this one? See everyone now. 0, 1, 2, 3, 4, 5, 6, 7, 8. See this one, 2 power 8, 8th bit is 1. 2 power 5, 5th bit is 1. First 4 people, 1100. First 4 people, 1100. Remaining, I think, zeros you can keep. This is exactly 300 binary number. This is exactly 300 binary number. But remember, this 300 binary number is exactly this one. But it will store in integer, 2 bytes. Right? 2 bytes required. Remaining people namesake, 9, 10, and so on, 15. So these are zeros. 0 to 15 means totally 16 bits. So, right, this is 2 bytes. 300 is arranged in 2 bytes. But see the interesting answer. Everyone listen. Everyone listen. Everyone listen this. I'm expecting answer. Everyone listen. Listen carefully. Everyone listen this. I'm expecting answer from you. Right? See this. Because of A is A, because of A is a integer, see this one, in 2 bytes. A is a integer. See this one. Very, very interesting line. Very, very interesting line. Please listen. A is an integer. So people will think that when you say A is an integer, see this one. People will think like this one. A 1000 by 1000 on words 2 bytes, 300 will store. People will think this is the way how A will store. A 300, 1000 is the address, right? People will think that actually this will store like this. People will think like this. But actually inside a computer, it will store like this. A 2 bytes, it is 1000, it is 1001. In 2 bytes, 300 will store. 300 will store in 2 bytes like this. But how 300 is like this? Everything is binary format. Everything is binary format. Can you listen? A in 2 bytes, it is 1000, it is 1001. 2 bytes, 300. How? Some people are asking how. Very, very interesting. It's a very, very interesting. Can you see this one? In this 300, which you convert into binary format, in this 300, which you convert into binary format, if you observe, see this one, it is a lower address. It is a higher address. 2 bytes are the lower address, higher address. Remember, lower address, what are you storing? Listen everyone. Lower address, what are you storing? Lower address, what are you storing? Remember, in these 2 bytes data, whatever already ready, in these 2 bytes data, what will store here? In the lower address, what are you storing? Remember, lower address, lower byte I am storing 0 to 7. Lower address I am storing lower byte. So which will goes to 0, 0, 1, 0, 1, 1, 0, 0. In lower address, what are you storing? Lower address, lower byte I am storing. See, I am writing here. See this one. I am writing here. See this one. Lower address. What are you storing? Suppose in lower address, if you store lower byte, that is called little endian. This is called little endian. Little endian. Little, little endian. Endian. Little endian. Little endian. So if you want, I will write little more bigger. Lower address, what are you storing? Lower address, are you storing lower byte? This is called little endian format. Little endian format. By default, little endian. Remember. Suppose some people are asking, sir, in the lower address, can I store higher byte? This is higher byte. Lower address, right? Are you storing the higher byte? That is called big endian. Lower byte, I am storing lower address. Further people will continue. Next lower byte. So means we will come here because we have only 2 bytes. So 0, 0, 0, 0, 0, 0, 0, 1 like that. Lower address, what are you storing? I am storing lower byte. Further we will continue. So in the data from the rightmost onwards you are storing. In the address leftmost onwards you are going. This is called little endian format. Remember, you are 300 when you declare like this. When you declare like this one, you may be imagining like this, which is nothing but you may be imagining like this, which is nothing but it is the actual story which is going to be happening. It is the actual story what will happen. In the lower address, this is the lower address, remember, lower address. It is a higher address. Lower address, what are you storing? Lower address, I am storing lower byte. Right? Next one, it will continue further. Next lower, suppose more people are there, more bytes are there. Next lower address, next lower byte. So it will start from here. It will start from here. Lower address, what are you storing? Rightmost one. What do you mean? Lower byte we are storing. Oh, lower address, I am storing lower byte. Little endian. Remember, little endian means both are low. What do you mean? Lower address, you are storing lower byte. Some people are asking what is the big endian. This may be the case, big endian. Lower address, what are you storing? Higher byte I am storing. This is called big endian. This is called big endian. Lower address, what are you storing? Yeah, that will also correct. Right? Both are different, two different techniques. Most of the people who are manufacturing hardware, they are doing little endian. The system which I am using, that is also having little endian. Right? Now understand. You will get the clarity. Within few minutes, you will get the clarity. Please listen. Please listen, everyone. I am using another color. Careful. I am using another color. See this one, first line over. See the second line. Char star B, pointer variable. Char star B. See this one. Char star B. B is a pointer variable. Okay. Char star B. B is a pointer variable. See this one. B saying that I am expecting. B saying I am expecting address of a char. But unfortunately, I have address of a int. A is the integer variable. This is address of a int. I have a address of a int, but you want address of a char. So I done the typecasting. See, character pointer. I convert it into character pointer. So now also it is 1000. Now also it is 1000. Now also it is 1000. Right? But it converted into character pointer. Some people are asking, sir, why sir? Before conversion also 1000. After conversion also 1000. Why? Before conversion also it is address. After conversion, see, char star, that is also address. Address means normally 8 bytes. To store address, 8 bytes required. So what I mean to say is 8 bytes person, if you convert into 8 bytes, you don't lose anything. Previously is an integer pointer, integer address. Address 8 bytes. Now you are converting into character pointer. It is also address. Address, if you convert into address, you don't lose anything. That is the reason. Before also 1000, afterwards also 1000. Remember, you may say that, sir, why are you converting? This person saying, I want address of a char only, but you have address of int. Remember, it's address of int, but I want address of char. So conversion required. But remember, left hand side also address, right hand side also address. Address means 8 bytes. So you have a 1000 which is there in the 8 bytes because of address. You are storing in again address, right? Which is 8 bytes. 8 bytes, if you store in 8 bytes, you don't lose anything. So now I am giving, see this one. B is saying I want address of a character, but I have 1000, which is the integer address. I typecast it to character address because of address. Previously 8 bytes it is stored. Now also 8 bytes it will store. Now see this one. B will point here, which is nothing but B is pointing here. See this. It is here. Remember, B is a character pointer. Remember, B is a character pointer, which is nothing but, everyone observe, which is nothing but B 1000 is pointing here. Variable means inside. 1000. Variable means inside 1000. Remember, and not only that, B is a character pointer. Remember, B is a character pointer. Variable means inside. See, B is a variable. Variable means inside. Now understand. Print B. Variable means 1000 will be printed. B plus 1, because it's a character pointer. Character pointer will increment by 1 byte. Character pointer will always increment by 1 byte. So this is 1001. This is 1001. Remember, before also, see this one. Before also address. Ampersand A address. After conversion also address. Both are addresses, means both are 8 bytes. But it is an integer address. But this is a char address. Okay, fine. Everything is fine. Now listen. Star B. Because of is a character. Listen, is a character pointer. Character pointer, when you say star, 1 byte only it can access, even though a lot of data is there inside, right? Character pointer. So I think B 1000, star 1000 you done. So remember, character pointer will always increment by 1 byte, but when we say star, 1 byte data only it will take. 1 byte data. It will take 1 byte data. See, 1 byte data it will take. Wherever he is pointing, I think B is now 1000, right? Star B. Because it's a character pointer, it can read only 1 byte. I think if you observe clearly, this is 44. This is 44. This is, sorry for this, it is 12. It is 12. Total 44. This is 256. This is 256. This is 12. I think first byte is 44. So remember, here 44 will be printed. Now some people are asking B plus 1. What is the answer? B is a character pointer. You will always increment by 1 byte. When you say star, so I think this area you will access. So I think this area, if you observe 1, this area if you observe 1, this is, it will print 1. It will print 1. The reason is you are going byte by byte. If you access at a time, if you access all the people at a time, it is 300. But when will you go byte by byte? When you go byte by byte, you will see byte only. First byte 44, second byte is 1, like that. Right? But some people are asking, sir, ready sir, if I say here, print A, what will print? I am not done any change. When you say A, 2 bytes they will read at a time. When you read 2 bytes, A means what? 2 bytes. 2 bytes if you read at a time, it is a 300 actually. Actually it is 300. Actually print A, it is a 300. But because of you done the typecasting to character, you are going byte by byte. First byte 44. Second byte 1 there. If you read at a time, see, actually it is not 1. If you read byte by byte, it is 1. Actually, it is a 2 power 8. It is a 2 power 8. See, this is 2 power 8. 256. Because of you are going byte by byte, first byte 44 is there, second byte 1 is there. First byte 44 is there, second byte 1 is there. Right? First byte if you observe 44 there. Second byte 1 there. Second byte 1 there. 44. Okay? Are you comfortable? Some people are asking, sir, what are you doing? Reddy sir, what are you doing? I took one integer variable. I kept one pointer variable pointing, which is a character pointer. For integer, how can I keep the character pointer? Through typecasting I done. What is the character pointer opinion? What the character pointer will do? Always it will increment by 1 byte. When you say star, it will give 1 byte. 1 byte incrementing, 1 byte taking data. So if I ask the character pointer, read the data, he will read 1 byte. Wherever he is there, 1 byte data he will read. If I ask the character pointer increment, he will increment by 1 byte. Now because of his character pointer, it will return the ASCII value. If percentage C means character, it will print. Percentage B, ASCII value will print. Right? Fine. I think in the next class, you will get the more clarity. In the next class, you will get the more clarity. Tomorrow, 2 more problems are there. I will give those also. Tomorrow, 2 more problems are there. I will give those also. Okay, fine. Now see this. If you want, I can type also. Just give me 1 minute. Just give me 1 minute. I'm just typing also. Just give me 1 minute. I'm typing. I'm typing once. Yeah, yeah, I think fine now understand. Now understand everyone. Now understand everyone. See the output. See the output one time. See the output. This is the output. So first address. If you see the first address, see B address. If you see the B address, I think it is not slash and it's not a slash and let's keep slash T so that both the things will print in one line only slash T. Now I am executing now. Now you will see more clarity. See this one. If you see the first address, 88. See the first address, 88. First address is 88. Second address is 89 because character pointer will increment. See, B is a character pointer. Character pointer will increment by 1 byte only. Character pointer will increment by 1 byte only. And one more thing I want to say to you. What is the ampersand A address? First of all, what is the ampersand A? I will print that also. You will get more clarity. Before typecasting, after typecasting, same thing will be there. Both are same. Before typecasting, after typecasting, same. The only thing is, let me check here. Permissions will change. Previously it is an integer address, now it is a character address. So I am writing here A. Ampersand A. Now observe here. So printf %u slash a. See, this is I think A address 1000. Same address 1000 I stored in the B also. But it is a character pointer. But character pointer will increment by 1 byte. So 100 becomes, see, 100 become, forget about big number, last 3 digits you see. 100 become 101. Now see the data. First byte data 44. What is the meaning? Lower address contain lower byte. It is a little endian. This system follows little endian. See, 44 printing first. 44 printing first. Next one 1. Actually, if you do properly, it is a 256. But because of you are going byte by byte, it became 1. So this is right. Some people are asking, sir, after doing this much story, what is print A, sir? If I say print A, what will print? Remember, A not updated at all. See, A not updated here. A address you took, you done some changes. A not updated. A will be as it is. A is 2 bytes data, integer. Integer you are reading means 2 bytes you are reading. 2 bytes you are reading, so nothing, no change. A will be 300 only because nowhere A updated. Please try to understand. Nowhere A updated. A is not updated anywhere. A is not updated anywhere. So A will be 300 only. No change at all. See the outputs one by one. So 148 A address, same address I stored in the B, 148. But because of its of character pointer, it will increment always by 1 byte, 149. So 44 is the first byte, second byte is 1, and 300 is the A. 300 is the A actual value. Starting also A300, ending also A3 because A not done anywhere update. See, update means assignment operator left hand side A should be there, nowhere there. So this is. Let me know anyone having any objections. Ready, sir? I have this doubt. You ask me, I will help. Yeah, 2 consecutive cells. If you say in the place of percentage D, if you say percentage C, ASCII values will be printed. ASCII characters will be printed. Let me print it. You want ASCII characters, you can print it. Percentage C. Right, I think now 1 by 1 character we are going, so characters will print. ASCII characters will print. Let's check. Percentage C, star B plus 1. 44 and 1. I think, yeah, okay, fine, that's okay. It's, I think, maybe some net issue, whatever it may be. It's a blinking. So I may stop once and I may run again. Yeah, so now series. Now series. What it is printing series? 52 address. So B also 52. B plus 1 also 53. So the data, I think, see, I think some characters are printed which are not visible. See, the characters which are printed, they are not visible. They may be some other character. You see, one may be comma, one character is printed comma, one character may be printed comma. That may be the case. That is the reason for this. That is the reason. One may be comma, one may be something else. So fine, anyhow. Fine, perfect. One may be comma, one may be something else, not printable, whatever it is. Is it okay now? Now my question is, my system following little endian or big endian? My system following little endian or big endian? See, suppose if one will be printed first, then big endian. Percentage D, starting printed one, then it's a big endian. Starting printed one, then it is a big endian. Understand? If starting itself, see, starting one printed, then it will become big endian. So let me go to my code here. See this. See this. This one. See this one. Starting itself one printed, it's a big endian. Starting 44 printing, next one printing, it is a little endian. So you can verify your system is which endian. You can verify your system is which endian, big endian, little endian. You can try like this. So remember this only they will ask. I seen the previous paper, typecasting with pointers only they will ask. So I took one integer, with the help of character pointer I am accessing. I took one integer only, but I am accessing it with the help of one character pointer. Character pointer will always increment by 1 byte. Character pointer will access always by 1 byte. Some people are asking, sir, while typecasting, any change there, sir? No change, because before typecasting also address. Here also address. After typecasting also address. Address means 8 bytes. 8 bytes you are storing in 8 bytes, nothing you lose. 8 bytes you are storing in 8 bytes, you don't lose anything. But the only thing is, right, integer address, you give into character pointer. From now onwards, character pointer will behave like character pointer. 1 byte incrementing, 1 byte reading. Okay, fine. I think absolutely fine. We done really good work. Any doubt there? In the next class, 2 or 3 problems are there. Then you will get the more clarity. In the next class, 2 or more, right? 2 or more problems are there. You will get the much good clarity. Putin should be received by Modi ji only. Yes, true. Can we stop now? Can we stop the class? In tomorrow's class, we'll see few more problems. See, remember, pointer typecasting only required. Remaining typecasting is not required. If you find at anywhere any problem, let me know. I am ready for open challenges. Any difficult problem you find out, post in group. Any difficult problem if you find out, post in group. Right, fine. Tomorrow we'll see some more good problems. Right, thanks everyone. See you in the next class. Bye.